So welcome to our free GMAT prep hour. It is August 5th, 2020, and we are still mid-pandemic. Who knew? I'm really excited this week for two reasons. One, it was my birthday 2 days ago, so fun. Pandemic birthdays are interesting. And then tonight is probably one of my favorite GMAT topics ever. And it's one that I have students ask me about all the time, class students, tutoring students, and even these prep hour students. And I've never really sat down and put together a full lesson about this topic until now. And so I'm actually really, really excited about it. And thank you, Kimberly. I appreciate the birthday wishes. So the plan for this evening is to discuss how to get better at recognizing what to do by knowing the code. So if you've taken a class with us before, if you've read any of our books before, if you've used our Navigator solutions, you've probably seen this terminology floating around, but we don't have anything specific dedicated to it, like lists of code, for example. But this idea of know the code comes from the idea that the GMAT is not really a test of content. It's not really a test of do you know your exponents, but instead it is a test of creativity. And so can you see what the GMAT is saying when they're not actually saying it to you? They often cloak what they want you to do in hidden language, but throughout the exam, quant and verbal, they are constantly trying to feed you clues. And so what we want to know, this like know the code, is really like recognize the GMAT clues. And these cross all question types. This isn't just a quant thing, although we are going to start there because sometimes they're the easiest to see or to at least comprehend. Code signals are everywhere, all through reading comp and critical reasoning and sentence correction. So tonight we're going to see a little bit of everything. So bear with me. I do want you quick on the keyboards because I'd love for you to jump in and give me answers as we work on problems tonight. But I want to start this conversation with a quick sort of discussion of like, well, how do you review? What does that mean? Right? What does it mean to review? And then really what is this code that I'm talking about? And then we'll talk about flashcards and how important know the code flashcards or recognition flashcards are to your studies. So just a quick sort of, give me a little feedback here. I want to know how you guys review questions. Does this sound accurate? So maybe type in the chat window. You review the ones you get wrong. You read the explanation, make sure those make sense. And then you might even do the problem over. I mean, maybe right away, but you will sometimes do the problems again later to see if you can get them right the next time. Does this sound familiar? Yeah, A and B for the most part. Yeah. Yeah. Okay, cool. Michelle is telling me reviewing the ones I had correct as well. A and B for sure. Lots of people don't always do C, right? There's not always a lot of this like, oh yeah, maybe I do it again. It's rare that people review the ones they got right. That's super rare. And in general, yeah, and I get it, Jay is like, I struggle with C for sure, right? We have limited time, lots of questions we want to do. Whitney, you want me to do the same question like 6 times? Who has time for that, right? Who has time for that? But what's really important is that if you're going to do a question, I want you to like extract all of the gold from that question. And the thing is that sometimes that can feel really time intensive, right? Like how long is it going to take me to review, Whitney? How much do you want me to do? And like how many times am I redoing it? But I do have a couple of quick suggestions. And then these know the code flashcards can not only, like get you triple, quadruple the amount of goodness out of each individual question, but they won't take you all that much longer. So the first thing I want to make sure that you guys are doing is reviewing it all, and don't do a problem if you're not going to review it right or wrong, right? Just don't even bother. It's not even worth your time, right? So the idea here is that if you're going to do a problem, you want to be able to spend about twice as long reviewing it as you spend doing it. So if you think about a quant problem on the GMAT, the average time to do a quant problem is about 2 minutes. You'd want to be ready to spend about 4 minutes to review, time to kind of poke at it. And you should include in this review, not just, okay, did I know how to get this question right or wrong, but also what was your process? Right? Like, is there anything that you could, I love James mentioned, look for a more efficient way to do problems even when you get them right. Like, what is your process? And it might be that you can find more efficient processes for both right and wrong. So maybe you kind of, more than anything, got lucky. And so this is why it's so important to review even those right ones. Maybe you got lucky. Maybe you used sort of an inefficient process that was fine for this level problem, but if the problem got harder, you wouldn't be able to get it right. Or maybe there's just an easier way to do it than the one that you thought of. And so you got it right in 2.5 minutes. But if you would kind of recognize this other solution method, you could have finished in 1.5 minutes. Right, with less work, less brain power involved. So the key is, at least initially, for any of this to work, you need to review. And as part of this review, of course, you would like to start to diagnose, right? Like, what are the types of things that you're missing? Are you missing things because there's, a chapter of a book you haven't covered yet? Right? Holy cow, I can't remember exponents from, 7th grade. Or maybe I'm just really not prone to, I just don't write things down. And so I'm making a lot of careless mistakes. So your job as part of your review is to diagnose errors. But here comes the one piece that most people don't do. And this is what I think is the most important. You should walk away from every single question with a takeaway. And a takeaway is not always negative. Sometimes a takeaway is like, that was a nice job, Whitney. You wrote everything down, right? Like, sometimes your takeaway is to be proud of yourself and remind yourself to do the same thing again next time. But often takeaways are a way to say, okay, here's the thing. The one thing, if I can only remember one thing about this question, what am I going to take with me? And ideally that thing is portable. And so what I mean by that is that your takeaway isn't just, here's how to do this problem. Your takeaway is more of a, when I see this kind of thing, I want to behave this way, right? That it's more of a, when I see or notice or recognize, I want to think or do. And so this is really the heart of the code, this idea of getting yourself ready for the next time that you do a problem, right? So how are you going to recognize a similar problem? Because unfortunately, unlike most of our tests that we've taken, all the way through school, for those tests we were given, questions throughout the semester, maybe even a study guide, and all of those things contained, in many cases, the exact questions that were going to show up on test day. And so if we just did enough of them or did them enough times, we'd literally just do the same thing on test day. But many of you have already experienced the GMAT is not like that. The questions that you'll do in practice are similar to the ones that you'll see on test day, but they're not going to be the same. So you can't get kind of ready for the real exam if all you're doing is doing a bunch of questions and trying to memorize how to solve those questions, right? You don't want to only know how to do a question when you see that question. You want to be able to recognize that question's cousin and its aunt and its uncle, and maybe it's like third cousin once removed. Like, I want to be able to see the lessons from that question in future questions. And this comes from recognition. So like, what are the signals? Right? And maybe there's an alternative method. What are the signals for using that method? I really want to learn how to work backwards. What am I looking for in questions to give me the signal that working backwards would be a good idea? I really want to test cases and data sufficiency. I really want to look for subject-verb agreement errors and sentence correction. I want to be very efficient at how I eliminate answer choices in critical reasoning. What should I look for? Right? And so all of this is this, like, what are the signals? What are the typical trap answers? What are some common techniques? And how do I recognize when to use them? And then, like, what are the habits that I need to be putting into place? Right? I don't want to make these careless mistakes. Can I identify why? Right? Am I never writing down steps? I'm just sort of skipping them. And so part of the review is that I want to know, I want this code, I want to know what is the clue to help me out next time. Yeah. So I don't know about you guys, but I think that a really nice way to talk about this, like, know the code, and then to talk about, like, the importance of flashcards, is to do some questions. So hopefully you guys are feeling up to some questions today. Before we get into one, I'm a big believer in the fact that we want to kind of take a breath, reset at the beginning of every question. If that's not something you're already doing, I encourage you to very strongly. So we're going to do this together. We're going to take a deep breath. You're going to get a pen, you're going to get some paper, and then you're going to give this question a try. Our target time is 2 minutes. I'm going to set a timer for you, counting up, so you can see how long you take. As you find an answer, please send it just to me. So send it to all panelists as opposed to attendees so I can see what you guys are thinking. All right, I'm getting lots of answers in. And so what I'd like to do, we're still a little early, right? You would have an average of 2 minutes per question for these problem solving questions. But I'm going to stop us a little early because the point of this question isn't to solve it. The point of this question is to start to see the code. And I love this. So, I'm going to shout out to Jay. Jay says, hey, the code's of this variable. There's a variable in the answer choices, right? Like that would scream at me, variable in the answer choices. Maybe I should plug in. That's one of them, right? That's one of the codes here. So let's say you did this problem and you sat down and you did a bunch of algebra and you tried to like factor some of these things and you started like running through math and got stuck. Right? One of the codes that you'd want to see is that all of the answer choices have variables in them. And variables in your answer choices are a really nice clue that picking your own values for X and plugging them in might be a great test. There's another clue here. Right? There's another code that the GMAT's giving you. Does anybody know what it is? It's specific terminology. What is that code? Nice. I've seen that this is coming in from a few people. Beautiful, beautiful. Ozzy, Estrella, beautiful. Must be. Dominic's in there. Jay's in there. I love this. Must be. Okay, so we've got two codes in this problem. We've got variables in our answer choices. We've got must be in the language of the question. And what that screams for me is that we would like, if we do this problem, and we didn't get it right, that what I would have wanted to do is plug in. So maybe I choose, which of the following expressions must be even. So maybe I'll just pick what happens when X is 1. So answer choice A would be 3. 1 plus 2 plus 2 is 5. 1 plus 5 plus 6 is 12. 1 plus 6 plus 4 is 11. 3 plus 3 is 6. If it must be even, then anything that spit out an odd isn't going to fit that criteria. So I'll try another number, X equals 2, and I'll just test the remaining. So 4 plus 10 plus 6 is 20, or 6 plus 3 is 9. E fails. The correct answer is C. So as we work through this problem, again, I'm less concerned about, like the actual content underneath this. Yeah, you should know what even means and odd means. But this question, my takeaway might be that I should pick numbers. And here are some scenarios. So I see this question. If I got this wrong, I'm going to build a flashcard. And it's not a flashcard with some fact on it. It's a flashcard for recognition. So on the front of it, I'm going to put some portion of the question and the answer choices. And then on the back, I'm going to make a note to myself like, okay, so I see variables in choices. I see the language of must be true. I want to think, so what's the do that I'm going to do? Pick values that fit the constraints and plug in. Eliminate. So I'll throw all that on the back of my card. I might throw the answer in if I put the entire question on the front, but the idea behind this flashcard isn't so that I come back and do this problem repeatedly. It's to extract the idea that when I see this sort of wording or I see this in the answer choices, I know what I want to try, right? So this is the idea of a know the code flashcard. And so this is what we're going to do. This is what we're going to do for several more questions. So you guys ready to do another one? I'll take hands up. Smiles, thumbs up. Cool. All right, let's do it. Let's take a deep breath. Good luck. Send me your answer when you think you All right, answers coming in, looking good. And once again, I'm just going to stop us a little bit early. And so the last question that we did, the code was about the recognition of when we could apply a certain strategy, the strategy of like picking numbers, plugging in smart numbers, right? And this one I put out here for a slightly different reason. This might be if you were to work on this problem and you weren't sure how to do it or you got it wrong, this would be a really great content-based problem. And it's this idea of, okay, if I see these sort of like, these like numbers, but there's a variable in an exponent, then there's only really one way to solve this. To solve a problem where I have a variable in a power, especially with an equation, I need to simplify my bases on both sides. I need to combine my exponents, and then I might need to refresh those rules. And then I'm going to set the powers on both sides equal to each other. So if we start to break this number down, right, I'll write it on my page. 4 to the 5th, 8 cubed is 2 to the x. 4 is the same as 2 squared. 8 is the same as 2 cubed. So I can get everything into this base 2. But now I have to know my exponent rules. So when I raise a power to a power, I multiply. So 2 to the 10th, 2 to the 9th. And then when I am multiplying my same bases, I keep the base the same, but add my exponents. And so this would be 10 plus 9 is 19. The only way for the left-hand side to equal the right-hand side is if the powers equal, and that is how I solve for a variable in an exponent. Correct answer would be E. So again, maybe this was no big deal, right? Maybe this was fine, but it's a good chance for you to start to see like, yes, I do know how to solve problems when they look this way. This is a problem where you're like, I didn't recognize this, what to do. Then maybe what you want to think in this case is I might write in a little note to myself, like, okay, I saw exponents. Clearly that's what those little symbols are. But then other thing I noticed, variable in an exponent. And how do I solve that? That means I need the bases equal on both sides. And then if there were any of those exponent rules that I wasn't sure of or that I screwed up, I might add some of those exponent rules. And I might even add the solution to this problem down here so that when I see it next time as a flashcard, I can practice. So what we're doing is, sometimes we're looking for know the code in terms of a strategy, like testing cases. Sometimes our know the code is, hey, when I see this, these are the rules that apply. These are great for geometric shapes. So let's say you do a problem, and in the problem there's a circle with a triangle in it, and you didn't make the connection between the diameter of the circle and a side of the triangle. Like you just missed that. You didn't know the rule that applied or how to connect those things. Make a flashcard with that weird, circle around a triangle on the front, and on the back say, here are the things I want to notice. I want to know that if, one side of the triangle is the diameter of the circle, blah, 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 blah. Like these are the rules I want to know. And so we identify our takeaways, honestly, by like doing questions wrong or inefficiently. And so it's good. What we want to do is we want to do questions that we get wrong. Like that's how we learn. It's really important. All right. So we've done a couple of these in our good old fashioned problem solving. So let's dig into some other areas. We're going to do a little spotlight on some data sufficiency, same idea. Just so you guys know, the idea of data sufficiency is that and I'll give you guys the answer choices, but for those of you that haven't done much studying up till this point, data sufficiency is all about process, right? So it's all about how you get to an answer. It's not always the case that you definitely get to an answer. But we're going to focus on a specific type today just because they tend to give people the most problem or like the biggest problem. But so here it goes. Yeah. We'll take a deep breath. I've got your data sufficiency answer choices on the screen. I want you to send me what you think the answer to this question is when you think you've got it, same amount of time. All right, so once again, if you're working towards an answer, no big deal. I'm stopping us a little early. I don't expect you to have one yet. I just wanted you to get kind of a jump on where this would go. And the most common answer I got, far and away, was answer choice D, as in dog. Some with exclamation points because they were excited, and a lot with question marks because it's like, is it D? I'm not sure. So what I want you guys to notice, though, is that D is not the right answer. So here's the thing about data sufficiency. For those of you that chose D, the correct answer is actually B. So I got a little pieces here. Okay, so the correct answer is B as in boy. So statement 2 is sufficient, while statement 1 is not. If you said D, you said they both were. So you actually got statement 2 right. You evaluated it correctly. You just missed statement 1. I love this problem because it seems so simple. I mean, it's like a square thing, a square root, the word even. It's so tiny. Little tiny question. So I love a question like this because it's dangerous. And so maybe your takeaway, right? You make a flashcard and you're like, DS looks simple. You flip it over to the back, slow down. Now this one is actually one that even if you do slow down is super tricky, and that's why I like to put it here. And the reason why it's so tricky is because it really preys on some of the things that we as humans think naturally. So we make an assumption a lot about integer. A lot of times when we think about numbers, we only think about like the integer status of a number. But notice that nowhere in this problem does it say that P is in fact an integer. It asks if P is even, but I don't know if P is an integer. If P is a half, that's not going to be an even number. Now, the other thing that makes this problem particularly trappy is that we don't know a thing about P. I know nothing. I don't know if it's positive. I don't know if it's negative. I don't know anything about P from the beginning. What I do know comes from the statements. And so when I want to test cases, because this is what I'm going to do, right? This question is what we would call a yes-no question. And the reason why we call it yes-no is because the answer to that question is going to be yes or no. And when I have a yes-no question, I often want to think test cases, right? Try it out. Can I get a yes? Can I get a no? When I test cases, I want to be really organized. So maybe you thought test cases, but you were just like a disorganized mess. Maybe that's your takeaway. Maybe you thought test cases, you were super organized with a table, but you did what a lot of people do, which is start with something that you know nothing about. So you start with P and say, all right, well, what if P is 1? P squared is 1. Oh, this says that P squared is meant to be even. So that case isn't allowed. So if P is 2, P squared would be 4. This case is allowed. Is P even? Yes, P is even. If I picked 3, this would be 9. Okay, P squared is meant to be. Okay, so then 4. And what I start to notice is that for P squared to be even, clearly P had to be even. But apparently that's not true. It's not true that just because P squared is even, that P is, right? And I love this. Jay mentioned, like, I tend to be scatterbrained. My work is all over the place. This is exactly what I want to give you, is this like nice organization for testing cases. My first rule for testing cases, start with something you know. Anything. You know what I know here? I know about P squared. So I'm going to start a column that says P squared is even. So when it comes to picking values for P squared, I'm only going to pick even values. Once I choose for P squared, I'm going to then figure out if P squared is 4, what was P? And then I'm going to ask the question, is P even? So I always build a little table. So P squared is even. P squared could be 4 or 16 or 36, right? What other numbers could P squared be? Aha, beautiful, guys. What everyone is, like what a lot of people are typing to me and noticing is that P squared is even, but look at the weird P squares I picked. 4, 16, 36. right? I could have picked 64. I'm accidentally only picking perfect squares. So yeah, okay, let's pretend that p squared is 4. So if I square a number and it's 4, p must have been 2, and I'll check if p is 2, p squared is 4. Yep. Is p even? Yes, it is. But a lot of people are mentioning it could be 2, it could be 6, it could be 8, right? Let's imagine if p squared is 2, what squared would give me 2? What squared would give me 2? And it would be, yeah, guys, 1.4, or the square root of 2. And that's true. If p is square root of 2, p squared is 2. Is square root of 2 even? No, it is not even. And so now I have two different answers, a yes and a no. Statement 1 is not sufficient. If I went to statement 2 and did that same kind of step, then I'm going to start with the root of p, and I'm going to be smarter this time. I'm going to start with 2 because I know this thing is going to be even. The root of p is even. So if the square root of p is 2, then that means that p was 4 originally, because square root of 4 is 2. Yep. Is p even? The answer to my question is yes. If square root of p is 4, then I started with 16. I get a yes. If this was 6, I started with 36. I get a yes. If this was 8, this started as 64. I took the square root. I just keep getting yeses over and over again. And so that makes statement 2 sufficient. So depending on how you worked for this, right, how it worked for this, you want to think, okay, why did I miss it? Did I miss it because I wasn't organized? Did I miss it because I didn't start with something I knew? Did I miss it because I made assumptions about the word integer? That's what I'm going to put on a flashcard. If you assumed integer, you're going to put this question on a flashcard, right? And on the back of it, you're going to write something like, it doesn't say integer, right? Like a big note to yourself. It's like, it never says that p is an integer. You might put on the back of this, like, test cases, start with what you know. You might put on the back of this, organize your cases in a table, right? Like whatever the specific lesson that you're taking from this question, that's what goes on the back of your card. And then great question when you're testing, if it's the C versus E. I tested statement 1, it wasn't enough. I tested statement 2, it wasn't enough. So now I have to put them together. I will make a third table if it's not clear how to combine them into one. If I can, save the labor to just kind of quickly move one into the other, I will. But if it looks like that's going to be messy, I'll just make the third table. Anything to stay organized. Yeah. All right, let's do it again. Let's try another one. Take a deep breath. Good luck. All right, lots of answers coming in. This is a common example of what I might think of as this like more literal code. Like the GMAT's going to say something to you. They're going to give you a specific grouping of terms, and it's going to translate into something else. This is really common in Quant, and particularly in the areas of number properties. So things like positives, negatives, divisibility, primes, evens, and odds, that they'll say something to you without exactly saying it. And one of those clues in this case is inequalities relative to 0. So often when we talk about an inequality relative to 0, we are in fact talking about a positive or negative issue, not specifics. Now, this is a great problem to consider testing cases, but what I want to notice is that maybe when I'm testing cases, I'm not plugging in actual numbers, right? So the even problem we did before, which the volume must be even, we tested actual numbers. This is asking, is T positive? So instead of picking actual numbers, what I might want to try for this, at least first, is to test out scenarios. Like what happens when R is positive or S is positive, right? So for something like this, let's think about some organization. What they're hoping people think for statement 1 is that when they see this, R times S is greater than 0, they want people to think that that means both R and S are positive. But that's not true. If I see R times S greater than 0, what I want to read is same sign. Right? So this means that either R and S are both positive numbers, or they could be both negative numbers. Now, if I move to the next piece of information given, where S times T is negative, that means different signs. And so if S is positive, T is negative. If S is negative, T is positive. That means, is T greater than 0? Not in this case, but yes, in this case, not sufficient. Statement 2 is the gimme here. It's like, I just wanted to know about T and you told me about R. Ugh. So this might be a great one for a reminder of maybe start with statement 2. Right? Like that might be the lesson you took from this, was like, man, look how easy statement 2 is. It's like pretty obviously not sufficient, because all by itself, it certainly tells me nothing about T. If I put the two together, here's a perfect example to Jay's question from before. I would not make a third table. All I would do is draw a line through, or try to like kind of highlight with a marker the one line in table 1 that matches the information from statement 2. So statement 2 says R is negative. That means that this is the row that has to be true. If R is negative, that means S is negative and T is positive. So we get a definitive yes answer to our question. Sufficient, we have to put the two pieces together. It is C, as in cat. Yeah, and Jay said something else really lovely here, which is I tend to have like kind of feel disorganized, and so I avoid. Here's the thing, is that you will always avoid what doesn't feel comfortable. And if you want a technique to work for you on test day, you have to start working for it right now. And so you have to train to make it more comfortable. So you might start with really easy questions in the official guide just to practice, right? Like, okay, here's a question I can just kind of warm up. Here's how I like my table to look. Here's how I want it organized, rather than always trying a technique on the hardest problem you can find, right? Like that's not always the most fun. So what might my takeaway be? Well, you know, what's the GMAT actually telling me? I might make a flashcard of these literal symbols. No, and nice. Avery asked, like, I got the right answer, but plugged in with actual numbers. Here's a perfect example. You plugged in with actual numbers. Let's say that that took you a while, though, and you didn't feel confident. But then as you read the explanation, it was like, oh, I could have started with just testing positives and negatives. And then if I needed it, could get more specific, again, if necessary. That might be the perfect know the code flashcard, is that when you see positives and negatives. So for me, if I see evens and odds, I often test real numbers. But when I see positives and negatives, I test the general case of positive versus negative. Because then I don't even have to worry about like fractions or integers or big numbers or small numbers. Right? So that might be your sort of takeaway for a problem like that, is when positives and negatives, or when testing cases, can I start generic and only go specific if I need to? For something like this, you might want to write things like, when I see an inequality, right, relative to 0, I want to know that this is positives and negatives. And then I might write these little things back down for myself. Notice that x over y greater than 0 means the same as x times y greater than 0. Right? So don't let them hide it from you just by making it look a little different. Add those to your know the code. Off you go. Okay, so I told you guys, though, that this isn't just a quant thing, although I think for quant it's a little bit more obvious. So we are going to look at this in verbal. So we'll start with sentence correction, right? So we'll do a little spotlight there. Reminder that sentence correction is the GMAT's question that tests grammar, that you will have a sentence with some portion underlined, and then 5 choices. Choice A will be the original, and then 4 other choices that change up the wording of the answer choice. Okay, so take a deep breath. The approximate time for these, about 1:15, 1:20. And so I'll give you a timer. All right, lots of answers coming in, looking good. So let's say you worked on a sentence correction like this one, and you went through every single answer choice, and you read, 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 and you finally got to the right answer, but it took you a long time, and you didn't feel super confident. And then you read the explanation. The explanation says, hey, look at the answer choices first, scan them vertically, and see if you notice anything. Maybe just having that single clue to like, oh, look, is versus are. Whoa, if I'd seen that, look how much faster I'd have been. That becomes your flashcard. If I see a split in the answer choices, singular versus plural, I know what I'm looking for. Right? In this case, the question is asking the aspects of the global warming that most concern the scientific community are plural, because there are more than one aspect. I'm going to then write the answer choices A, B, C, D, E on my page, and I will physically draw a line through B and D. If you are not using process of elimination, put that on your flashcard. Next, I see are the risks that the polar ice caps will melt, comma, that the seas will grow too warm to sustain marine life, comma, and that violent weather patterns may result. If you didn't catch this as parallelism, then you would want to add that to your list. I see comma and, I see a list. I want to think about making those items parallel. Right? As you learn more grammar, this might be something you add. You might add the grammar rules for it. So at the very end of this list, my comma and, I have a third element that reads that violent weather patterns may result. And so it's got this that here. The first item says risks that the polar ice caps will melt. So wouldn't it be great if I had a list that said that the polar ice caps will melt, that violent weather, that the seas will grow too warm? And we have that. It only exists in answer choice C. In A, the risks that the polar ice caps, but the seas will grow doesn't fit the pattern. And in E, the pattern changes, and there's not even a that at the beginning of the list. And so this that out here at the end isn't appropriate. The only one that has both correct subject-verb agreement and correct parallelism is answer choice C. Any issue on sentence correction can end up on the back of a flashcard. In fact, right, if I didn't see this piece, I'm going to write the is versus are. I'm going to put on the back, notice subject-verb agreement, right, single versus plural. If I missed the comma and outside of the underline, lots of times people don't read past the end of the underline. I'm going to make a reminder on the back of my card. So I'll put the whole question on the front, and then I'm going to remind myself, read past the underline. The stuff out there is as important as the stuff in the underlay. Right? So whatever the thing is, what was the grammar issue that if you'd noticed it, you'd have gotten it right? Or what is the process or technique that if you had done that, you'd have gotten it right faster? Right? These are the things that you'll make for your card. Right? Subject, verb. Let's try it again. Take a deep breath. Good luck. This sentence correction problem illustrates one of my favorite topics that so many people miss, and it's the intro or lead in modifier. Whoever was at age 4 had better be the person we're talking about here, right? And it may be, you mean because of the lower, like I mean, that's part of it here. It's not necessarily, I don't know that that's why I would kill it off for that. I had a question about Europe's capitals. But in this case, the big issue is at age 4. Is it Mozart's father taking Mozart on a tour of the capitals of Europe when Mozart's father was 4? That doesn't seem right. It doesn't seem like at age 4 Mozart's father was doing this. It seems like at age 4 Mozart was doing something. And so we can actually eliminate any answer choice that doesn't put Mozart himself right after that introductory modifier. So I kill off. A, B, and E are all gone. From there, I'm literally going to compare the two. So accompanying his father on tours of the capitals of Europe, on tours of Europe's capitals. I'm not going to make a fight about that one. To demonstrate his own musical talents, to demonstrate his musical talents. I'm assuming that the GMAT might think that just saying his musical talents is confusing, because is it the father or is it Mozart? And so saying his own might make it more clear. And so the correct answer is C. And so the big win here, though, is did you notice at age 4, comma? If you didn't, right, and if you picked A, B, or E, this is a phenomenal learning place, right? This is a great modifiers flashcard. And so at age 4, blah, 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 I want to think or do whatever follows that F at age 4 had better be the person who is age 4 during this sentence. So we start to make these know the code modifiers. Sentence correction is great. Tons of grammar to be added to these, tons of process pieces. So it's not just, do I know the grammar rule, but what are the GMAT's telltale signs, right? It's like a bad poker player. What are its tells, right? Like, what are its tells that are like, oh yeah, they're testing pronouns. Oh yeah, this is a modifier issue. Oh yeah, this is definitely structure. Oh look, there's a semicolon. I know what to do now. Passive voice, capitals of Europe and Europe's capitals isn't passive voice in this case. It's just a choice of how to use the modifier. And passive versus active is going to be always in the verb. But if they're testing like on that, which is the appropriate modifier, those are the types of issues I try not to get myself hung up on, which is also another thing. Like, let's say you got yourself hung up on some word choice and you were like back and forth and back and forth and back and forth. You might actually put that word choice on the front and then on the back be like, let it go, pick something. Like, don't get lost in the weeds. And just keep going. Because sometimes these cards are great for like, here's how I bail. Here's how I let something go. All right, and I know I see quite a few questions in the Q&A, so this is awesome, right? This is awesome. And I'll cover them in just a second, I promise. Before we do, we've got another spotlight. Let's spotlight critical reasoning. So a critical reasoning question, you typically have 2 minutes on average to solve. You're going to read the argument. You're going to read a little question that's going to tell you either to strengthen or weaken or find the assumption. I'm giving you just a partial CR. Right, so I'm giving you an argument, but only 3 answer choices just to make it a little faster for us to work through. So once again, take a deep breath. Good luck. All right. So for critical reasoning, we advocate a process that begins with reading the question first. We have some great free prep hours directly about critical reasoning. So we're not going to go into the process in detail for that, but we're always going to read the question first, which the following is an assumption. So if I know that I'm in an assumption question, I'm going to think to myself, okay, assumptions are things that are required by the argument, meaning that that answer choice has got to be true or my whole argument falls apart. And my city manager's argument is that our tourism industry is potentially in trouble because students aren't studying foreign languages. To fix that, we're going to propose a discount and hopefully, incentivize students to become fluent in order to get this discount. Now, an assumption in this assumption family, one of the most common wrong answer types for an assumption is an answer choice that strengthens. So it's yeah, that would be cool. That would probably be helpful, but it's not required. And so in this example, answer choices A and C are both nice to have. So these would strengthen the argument. If students did care about the reputation as a tourist, destination, that would certainly help. And if students who would have studied technical things choose to study a foreign language instead, also would be helpful, but neither of those are required, right? I don't need students to care about the reputation. I need them to care about this discount. And I don't need students from technical fields to switch. It could be students from other fields. It could just be students doing both, right? They stay in the technical field. They just develop fluency in a foreign language. It doesn't say they have to study a foreign language in school or major in it, just that they have to become fluent. So why is B an assumption? B is an assumption because if students who develop a fluency do move away, if they were to move away, I'm in big trouble. I'm in big trouble if my students go. So I need to assume that they won't move. I need to assume that they'll stick around. So we have a great technique called the negation test. Again, we cover this at length, both in our online free materials on our blog, but also in free prep hours that cover critical reasoning. But our correct answer is B. If you chose A or C, in this case, like a great flashcard might be to put on the back of it, like exactly what you're expected to come up with in terms of assumption, right? You might write the language of an assumption question as you find it. So maybe you read like this guy, which of the following is required, but didn't realize it was an assumption. Right? They often will say assume or require. And so I'm going to write something along those lines on the front of a flashcard, right? Like whatever the language of the question is. And then on the back, I'm going to think like, okay, trap answers are answers that strengthen. Or I want to use the process of negation to evaluate. Right? So whatever it is, what was the reason why you missed this? If it was something that's specific about assumptions, put that on the back. If it was something about critical reasoning as a whole, you might write just like when I see critical reasoning questions, I'll always read the question first. Right? Or maybe it's that when I see an argument, I'll actually put pen to paper and try to break it down. Right? But your job is to start to make flashcards that can kind of highlight for you, here's what I messed up on, here's what I want to do differently so that I don't mess up, or here's what I did, it wasn't efficient, this is what I'm going to do next time so that I am efficient. All right, last but not least, and I have some phenomenal questions in the Q&A that I will answer as soon as we finish this one. It is our final spotlight. This one is on reading comprehension. Now, I've picked a short passage with a single question. In general, reading comp, you would have anywhere from 2 to 3 minutes to read, and then another minute to minute and a half per question. I have picked a very, very short passage and a question that has relatively short answer choices to just sort of help us out with time. So I'm going to set a timer counting up. I will make sure that you guys have about 2.5 minutes to work on this one, so I won't cut you off super early. Do me a favor, just make sure that you take the time to read. You may not have processed all of the answer choices, but I care most that you read the passage itself. So take a deep breath. All right, good luck. All right, answers are coming in. So we have a passage about pre-mastication, which maybe isn't the most appetizing topic. Hopefully you didn't just have dinner. But the idea here, right, is that maybe you do this problem and you get it wrong. Correct answer is actually A. Maybe you get it wrong And you start to review, and what you realize is that you didn't actually understand what the question was asking for. That you saw would most likely agree and thought, "Ooh, I'm going to go be creative." Other language that gets in the same vein is like the passage suggests, right? Or the author suggests, making us think that it's our job to come up with some interesting or creative conclusion based just kind of like generally on what we know from the passage. Now, as far as the GMAT's concerned, this is what's called an inference question. It's also on critical reasoning. And your job on an inference is to not leap beyond the edges of the passage. It's not that the author would most likely agree. The author has said this, just maybe in slightly different terms. And so when I see a problem that says, suggests, infer, or would most likely agree, I know that I'm going to find an answer that I can 100% prove from the passage. Now, I had a bunch of people chime in with E, right? And E, fathers like mothers should be expected. We, maybe, but all we know is that according to this passage, that, fathers in some cultures also do this thing. It doesn't necessarily mean that the author thinks they all should, just that it's done. In fact, D is the opposite. It says that we didn't have enough digestive bacteria, and this is why pre-mastication is something that's used. I have no idea what's going to happen in the future, so I better be very careful. The author never tries to predict it. And I certainly don't know this extreme language that pre-mastication is only done in the developing world, and so I'm going to toss that one out. Where does A come from? Well, it says germophobic Western society eschews or rejects the practice, right? And what we know is that this practice does provide benefits to a developing baby. And so the fact that a Western germophobic society says we shouldn't do this, but it would provide benefits if we did, then this fear of germs might be depriving infants of this health benefit. And so that's where our answer choice A comes from. It's what the passage said, just kind of like twisted up a little bit and written a little bit of different language. And so if what you're finding is that you missed a question like this for that reason, you just didn't even understand that this was meant to be a thing where you draw your own conclusion, then this is a great flashcard to make, that you would do something very similar to the critical reasoning one, right? Like here's a lot of language around it. It can be inferred. Passage suggests. The author of the passage would most likely agree, inferred, and then there's a cool one, which would most weaken or strengthen. It's almost always weaken. This is an inference because somewhere in the passage mentions strengths. Like, oh, this conclusion's great for these reasons. I would weaken it by just like taking away a strength. So it's this funky language that's still an inference. Right? And so what I might do is if I encountered a question and didn't recognize that funky language was an inference, I would maybe put that on a card and be like, oh, this is an inference. Or if I put my inference question on the front, I'm going to write on the back, like, stick to the facts, don't expand beyond the passage, avoid strong language, avoid trying to predict the future, right? Like these are things that the author never mentions. Yeah. So here's the deal. There are a million different codes that can show up on flashcards. And no, we don't have some compendium of them because these are going to be in many ways like specific to the exact mistake or issue that you have. Just know that common codes can come from rules or formulas, right? Geometry, exponent rules, even just grammar rules. They could also be process codes. So what did I notice that told me to test cases? Oh, I should make sure that in sentence correction, I'm scanning the answer choices first. Am I using process of elimination? These could also be understanding codes. So when I see X, Y greater than 0, that means both the same sign. What are the wrong answer traps that go with this type of question? Did I recognize that it was a data sufficiency, yes or no? How do I approach inference questions? And in fact, there's even other cool ones like, if I ever see this problem again, dear God, help me like stop working on it 20 seconds in and bail. Like I have made flashcards that literally have like the mountain of text on the front of them as just a reminder to say, don't do this if I'm anywhere near behind on time. But then I'll have other areas where it's like, you know what, Whitney, it's okay, calm down, overlapping sets, you're really good at those. So if you see one of these, take a breath, slow down. You can spend the extra time on this type of question, right? Like give myself permission, right? So these comment codes, there's so many. There's so many. Because at the end of the day, honestly, the GMAT is about recognition. It's like, I did this problem. Can I find its cousin and its aunt and its grandkids and its stuff? Can I find those on test day? And so when I see those clues on test day, I can react a little more quickly, right? Because when you see a question, you're never going to know immediately what to do. But this knowing of the code can help you make that connection, you know, in 15 seconds instead of 45. So some great questions in the window that relate to this exact same topic. In terms of a lot of this, it is really helpful to have good explanations to pull from. We have amazing explanations in Navigator. Those cover all of the official guides back to, you know, the 13th edition. It's 2008 or something silly. But we do not have Navigator explanations for the supplements. So the verbal only or the quant only or the advanced quant guide. So just know that our solutions in Navigator really are only for the main official guidebook. I will say this, there are more than enough questions in the official guide to get anyone to a 750 that wants to get there if you're reviewing thoroughly. Had another great question that says, I tend to write down my takeaways, but don't always have a routine for going over them. Build a stack of flashcards. Make them separate, quant and verbal, because on test day, you'll only do quant, you'll only do verbal at one time, right? So give yourself a separate stack and then get up and do them while you're brushing your teeth, right? Like work on them while you microwave things. Just kind of carry them around in your pocket. You're waiting for a call to start and, you know, like your client's running a few minutes late to hop on the Zoom call, flip through some flashcards. Just sort of stick them with you and you don't have to go through the whole stack. These are a thing that you got a couple minutes, thumb through the flashcards. Got a couple minutes, thumb through the flashcards. Yeah. Another great one, should I be doing questions as sets and then review them all? Or do I do an individual problem and then review it? Answer is both. So you should be doing individual questions as part of your study. I recommend setting a timer counting up so you can see how long things take you. That way you can recognize like, well, I got this one right, but it took me like 7 minutes. Is there a way for me to do this that doesn't take 7 minutes? Or is this one of those flashcards I write and I'm like, don't ever do this problem again. That was crazy. But I'd also want to be able to do sets of questions so I can practice the balance of time. And so maybe I choose a set of 4 or 6 or 8 questions. And for those, I'll set a timer. I'll count down. I'll work on the set of questions. I'll take a moment and come up with any takeaways about the set as a whole. Like, what did I learn about myself? How was my timing? Those I'm probably not going to make a flashcard for. Those are just the ones I'm going to like gut check. Then I'll go back over each question. For any of them that I want to try before I review, I'll do the whole timer counting up business, try it again, then review. But in the middle of a time set, I'm not going to review, like stop and review, because the point of a time set is to literally practice timing. The point of an individual question is to kind of evaluate, well, how long do I take when I do sentence correction? Or am I slow at data sufficiency? Or am I getting any faster at testing cases? What's my organization look like? Oh yeah, so of course, right? There are a ton of previous GMAT prep hours. We have an entire YouTube video or YouTube station channel, whatever you call it, like packed full of them. I told you it was my birthday on Monday, so maybe I'm just like too old to understand YouTube now. But we have like 1 million free prep videos there. I have a bunch on things like picking numbers and plugging in. I also have a bunch on what I call like the first 30 seconds of like quick recognition drills, how you can start once you begin to know the code, how you can apply that, looking at new questions, like looking for ways to solve. And then I think I answered all of those. And I did have one more, and so I'll take that one. And let's see. Oh, confident about, and a couple more that were more specific. Comfortable with values and situations that you choose. Here's the deal, is when you're testing the right cases, there is no such thing as like knowing how to test the right ones. So what you need to practice is figuring out what the wrong cases were, right? And so as you work through like, God, those were terrible cases. What was I thinking? Like, why did I test those cases? And what I want you to start to think about is, why were those crummy cases, right? First off, why were they tempting to pick? But then why were they terrible to use? And so oftentimes when my students look back over it, they'll start to notice things like, oh, they were terrible because they were really big. Or instead of sort of picking numbers in order, like 2, then 3, and then 4, or something like that, I was like, pick a 7 and then a half, and I was like all over the place. So what you want is to actually pick bad numbers while you're practicing, so you can get a sense of like why they're so bad. And then there's your code, right? Like there's your lesson. Like, why didn't I pick a third for this? Well, because nothing was divisible by 3. So that turned out to be really terrible. Or, oh, I was supposed to raise this variable to the 20th power. Why did I pick anything instead of just thinking through the logic? Cool. Guys, I have a couple of questions in the Q&A that are more specific, so I'm going to answer those offline. But for those of you that need to take off, thank you. It has been an absolute pleasure getting to work with you. Please come look for us. You can find lots of free GMAT prep hours in all of our fun YouTube channel. We also have and that's supposed to say GMAT. I do that every time. But if you type into your search bar that the manhattanprep.com GMAT and classes, you can check out all of our upcoming courses. Any first session is free. You can try out our GMAT Interact product for free. We have a ton of free resources that you can take advantage of. You can find me on LinkedIn or directly through my email through work, first initial, last name, at manhattanprep.com. So always reach out if you're looking for some additional support while you're studying. We offer tutoring, classes, coaching, and the like. I had some questions about upcoming GMAT courses. As of right now, I'm not sure what the upcoming courses look like, but if you do end up doing GMAT Interact, you can always do one-on-one coaching with me, which is kind of like the cool, slightly less expensive option of tutoring. And there are lots of amazing coaches and amazing tutors and amazing classes available on our site. So I encourage you to come try out any of the stuff that we have for free. And otherwise, have a wonderful rest of your week, rest of the end of the summer. And, stay safe out there, right? Keep your masks on, keep each other safe, and hopefully we'll be on the other side of this pandemic soon. Bye, everybody. Have a very good one.